you're showing where carbon is moving in, say, the atmosphere. So there is like atmospheric CO2. That would go into, say, a plant.
And this is
in the process of photosynthesis. If you are doing cell respiration, that actually puts it back into the atmosphere. Burning of fossil fuels puts it into the atmosphere. They call that combustion as well. If things are dying, there's, in this picture there's like a little skeleton in the ground, and the decomposition puts this carbon into the soil. Carbon can sediment and become rocks. Oh, no kidding. Actually, in the picture, this is gonna be weird.
That's actually really
That's
good.
actually good.
It's a cow.
I know. Oh.
Methane is seriously part of the carbon cycle, and the methane from cow farts is literally a not insignificant source of methane in the atmosphere, and that would be atmospheric CH4. CH4. So that's what they're looking at with the carbon cycle diagram.
Just something like that.
Yep, you wanna show like how does carbon enter organisms, how does it leave organisms, and how does it like return to the earth, and combustion I should have up there. So like a car or a power plant and some smoke.
Could you say like decomp goes to the soil, it sediments into rock, the rock combusts into the atmosphere?
Totally. Yeah.
So you just have to create some sort of chain follow.
Yeah.
A dead dinosaur turns into gas.
Actually, well, no.
Oh no.
Actually, it's all of the oil that we have is a result of trees that got xylem, but there was nothing on Earth that could digest xylem, and so they all fell over and nothing ate them or decomposed them, and several million years of that before termites came around created this layer that turned into oil.
My mom was actually like randomly watching a documentary last night about that.
Could we
Was
not?
it Cosmos?
How
Okay,
long does it
no,
take to make
Could
oil?
we not replicate that?
That's
and-
how long
and,
does
like,
it take to make oil naturally? Like how long does that
A
take?
long time.
A few million years? I don't know.
Oh.
Oh man, we suck.
Guys, wind power, solar power, how about that?
I know, like what?
Just like a natural gas.
Okay, these three,
Yes.
Yeah.
and then we'll call it okie doke.
That was the carbon cycle.
So luckily, with our dear friend the monocot dicot drawing, there is not a heck of a lot as far as intricate drawing. It's more like labeling.
Which one
So
has the branching roots again?
the branching roots are dicots.
Okay, that's what I thought.
And do you remember the opposite of the branching roots?
The
Advantageous.
Parallel.
Not
adventitious.
adventitious, not advantageous.
They
Yeah.
parallel in the test.
Or parallel.
Sarah, the parallel stuff is the veins.
The veins of the
Oh
vein.
yeah.
Parallel
Thank
is
you.
All right. So, with tissue plan diagrams, what you're going to do is you can have the outer layer, and we'll call that the epidermis.
This is the monocot? Or
It's not either yet, but I'll do both. The one we've got up here is a dicot because of the organization of the tissues. But what you'll want is this layer of basically plant stem cells called the cambium. And it's good to give it some thickness. It's good to not just do it as a line. And then bisecting the cambium at several points would be the xylem and the phloem. And you should know which one is on the inside and which one is on the outside, because it is always true that the xylem is inside and the phloem is outside. And you can remember that because when they take maple syrup, they don't have to stick the syringe that far into the tree. They're not going all the way in, they would just get water. They're going a little ways in, and then the syrup sap in the phloem comes out. So you could label the phloem and the xylem and the cambium. And then after that, all you've got are the two layers sort of in between, and we'll just stick with this one because this one is called the pith. The most inner one is the pith.
What do you call it when there's both of them?
When there's both.
Like
you
the-
know how you bracketed the phloem and the xylem? What do you call that?
That's
Oh, thank you, sorry.
Vascular bundle.
Thank you, thank you. That whole structure is called a vascular bundle.
Sorry, Joey, I took your question.
No, you're good.
I find this funny that it's all recorded.
The only difference between this, which is a dicot, and a monocot would be it still has an epidermis, it still has a cortex, it still has a pith. The cambium, not so much, and the vascular bundles are random.
Wait, which one's
So basically, you're just leaving the inside and the outside. There's no.
Well, but yeah, but you would label vascular bundles, and you would label the pith and the cortex and the epidermis.
But no, that's what I mean. Like the pith and the cortex are just like more inside versus more outside.
Yep, the pith is the very center, the cortex is the ring around it.
So a monocot does not have a cane.
It doesn't have a
A
cambium,
cambium.
no. And a monocot has the striking feature of their vascular tissue is that it is disorganized, whereas dicot tissues are very nicely organized in a ring.
You know, dicot stems.
Yep, if you cut a dicot laterally and took a little pancake of its stem, this is what you'd see. We actually did that one year. It was hard, but we did it.
So where would you distinguish where the xylem and phloem are inside those vascular bundles?
The cambium is the border between the xylem and the phloem.
Yeah, but for the monocot.
Oh, I wouldn't label them.
Okay.
I would say vascular bundle with xylem and phloem, because it's kind of mixed around. Are we ready to move on? Sweet.
This may be something I missed, but what's the arrow to the middle point?
So there's still a pith and a cortex,
Mm-hmm.
but it's just not. There's no cambium.
It's the organization of the xylem and the phloem and the cambium that's all messed up.
I'm terrible.